Hello everyone. Good evening. Welcome back, and let's start. I hope that there are new candidates, I think. But anyways, coming back to the topic, in the last session we discussed about the AWS global infrastructure, how AWS global infrastructure will be looking like, and what is a data center. And then we discussed more on what I can say, data center and regions, availability zones. These are the concepts that we have seen, and then we discussed a little bit of networking concept. So in this session, we are going to discuss about the same. So we are going into the networking concept, which I have already asked you to check out the networking things like what I can say, binary configurations, binary to decimal configurations. These are all the things that I requested you to go ahead. Okay. So did anybody has gone through that configuration, like the binary to decimal changing and decimal to binary conversions? Yes, anyone? And one more thing that I am facing a lot of things, like I'm experiencing it. There are a few persons who are not properly giving their mobiles. I already discussed about this particular thing in the uh, previous session also. So please provide your proper number so that our DurgaSoft can easily communicate to you. So anyways, coming back to the things here. So have you gone through this binary to decimal number conversions? Why? Because to understand IP addressing, to understand the subnetting concept, you need to have the IP addressing things. Okay, binary to decimal conversion things. So let us discuss about what is an IP address. IP address is called as an internet protocol. Okay, what is internet protocol? What is a protocol? First of all, IP address is internet protocol. So what is the full form? The full form of IP is internet protocol. So here you can clearly understand that protocol. Protocol in the sense there are a set of rules that that it has to be followed to transfer the data from one system to the another system. For example, I am having a computer and you are also in front of your computer, and we are interconnected through internet. Okay, so when we are interconnected through internet, so there are certain rules and restrictions that should be followed to transfer my voice data to normal signals, and from there it should be transferred to you in a proper manner. So for that, in the networking, they have to follow certain uh, rules. Okay, so in simple, if I call them as OSA reference model, with the help of OS reference model, there is an option that we can clearly understand what are the 7 layers of data transmission and what are the protocols that they have to follow to transmit the data. So IP address is totally, or else IP is totally internet protocol. So which will be assigned to the systems, and with the help of that IP address, we can transmit the data. So how many types of IP addresses are there? In general, we are having two types. One is IPv4 and the other one is IPv6. These are the two types of protocols that we are having. So what is an IPv4? IP version 4. Okay, what is IPv4? IP version 4. So what will be there in the IPv4 concepts when we are discussing about the IPv4? So now what we have to discuss here? Anup, so when we are going with the IPv4, there are 32 bits, 32-bit architecture to transfer the data, and IPv6 is all about 128-bit architecture. Okay, so what is this 32-bit and what is this 128-bit? So to transmit the data, each and everything. For example, if you want to make a call, let us take an example. So you are having a mobile number, and you are having a mobile. Inside that you will insert a SIM card, and if you want to call your friend, your friend will have a mobile number. So that number, when you have, for example, somewhere like 9849368854, like that we are having, if you combine all these numbers, you are going to get a frequency. So when you are getting the frequency, so that frequency, whatever the frequency that you are seeing here, so at that frequency, the data communication will happen. Okay, so that's about how frequencies will accept, or else how frequency will work. Okay, so in the same manner, whenever the IP address is there, in the IP address, we will have a numbering system. In that numbering system, the 32 bits are now divided into 4 octets. So what is a bit? A bit is either 0 or 1. 0 or 1 is called as a bit. Now, whenever you are seeing here, these 32 bits, whatever the zeros and ones are there, they are divided into 4 octets. So how IP address will be there? If you see in the binary format, it will be looking like in this format, XXX. Okay, this is the first octet, and there will be second octet, and there will be third octet, and there will be fourth octet. Like this, we will be having 4 octets. And if you see in each octet, there will be 8 bits. So the size of 8 bits is equal to 1 byte. Okay, each why we need to go with only 8 bits. 8 bits is equal to 1 byte. So that's the reason they are differentiated these 32 bits into 4 octets. In each octet, you will have 8 bits. Either the bits will be in the 0 and 1 format. If you can see here, if you are able to understand what is this zeros and 1 combination. So for example, I have an IP address like this 101010, or else 00001010. If you can see in the first octet, you can have the numbering like this. So what is the binary conversion of this number? Whatever you are seeing, what is the binary conversion of this number? The binary conversion of this number is 10. Okay, so in the first octet, if you can see here, whatever the numbers that you are watching out, so they will be converted as a decimal number format. If you can see, so in the normal generalized system, whatever the laptops that you are having, in laptops, you won't find the binary conversion of IP address. If you can see here, it is in the decimal format, 192.168.0.112. So this is in the decimal format. Okay, but now when you see here, whenever we are discussing about the IP address, that will be in the binary format. So whatever the binary address that we are having, that will be converted as the decimal address. Okay, don't get confused about this. Now, this IPv4 address, whatever you are seeing here, this IPv4 address or else IP addresses are widely used, and we are not going to discuss about IPv6. Why? Because this is not at all right now. We are not utilizing that, or else no, majority number of the companies are not using IPv6. So we will be totally concentrating on IPv4. So for example, there is an IP address which looks like this. There is a computer, and this computer is having the IP address 10.1.1.100. This is the IP address of the computer. And this computer, whatever you can see the IP address over here, this IP address will be assigned to a computer. For example, my computer is there. I can assign that IP address to my laptop. Okay, for example, let me take any one of the things. I will assign like this 10.1.1.100. Now, when I assign this, automatically a subnet will be assigned. See here, you have entered an IP address that is missing its subnet mask. Please add a subnet mask. So, if you give the IP address, the systems won't accept. Definitely, you need to provide the subnet mask. Okay. So, what I am saying you here, if you provide the IP address, no system will provide, no system will accept. So, cannot provide IP addresses to a device without subnet mask. So what is this IP address? First of all, what is IP address? IP address is helpful for you to establish the communication between the devices. Now, what is the subnet mask here? So the subnet mask, whatever the subnet mask that we are describing. So what I am saying you here, without subnet mask, we cannot provide the IP addresses. Okay. Without subnet mask, we cannot provide the IP addresses to provide give the IP addresses to the system, definitely we need to have the subnet mask. So subnet mask plays a crucial role. Subnet mask plays a crucial role in the IP addressing concept. What is this crucial role? Why it is playing that? For example, so you are attending for the DurgaSoft sessions. Okay, you are attending for the DurgaSoft classes. Now, whenever you are attending to the DurgaSoft classes, they will provide you a roll number. For example, when DurgaSoft provides you a roll number, for example, the roll number for you is AWS. Some what I can say, AWS some 20 is the roll number. AWS 20 is the roll number. When AWS 20 is the roll number, now what you have to do? So your roll number will be AWS hyphen 20, and there is another candidate who is attending to the Python section. So for the Python student, they are going to give like Python hyphen 20. So if you see here, both there are two students who are attending two different classes, but their roll number is same. But as they are in the different classes, they will be the different network. Okay. So how we are going to identify? As we have the brains, our brain will say that so the student is having AWS hyphen 20, which means that this student belongs to AWS class and with the roll number 20, and there is another student with the roll number Python 20. So this student belongs to the class called as Python and with the roll number 20. So there are two students. So our brain will easily identify this student belongs to this category and this student belongs to this category. But machines, what about the machines? If a computer is there and a computer is assigned with an IP address, for example, I'm not talking about the computer here. Whenever I say computer, you can simply take the devices. Okay, any device, either it might be a computer or server. Okay, there is a computer in my company. This is the computer one, and this is the computer two. Now I am providing an IP address. Okay, just like I have provided the roll number for the student, I'm providing the IP address as 10.1.1. some 100. This is the IP address I am providing for the computer. And when you go to the another computer, for the other computer, I am going to provide 11. some 12. some 1.100. So this is the another computer IP. So now who will decide that these two computers belongs to the same network? By seeing into the IP address, is it possible for you to describe that this particular computer belongs to the same network? Is it possible for you to identify it? See, look at the IP address and tell me whether they belongs to the same network or a different network. Can you tell me that?
Same. Yeah, I think.
Very good. How you can say it's same?
100 is the one.
By looking into the 100, you can say it's same. There is 10 is there, 1 is there, 10.1.1.100 is there, 11.12.1.100 is there. How can you say it's same? If last octet number is same, how can you say that first of all?
Okay. 11, 10. 11.
Any another person want to try?
I think first 3 digits should be same in case they belongs to a same network.
How can you say that first 3 digits should be same?
Means
Is there any criteria?
no.
See,
We cannot recognize currently.
if I say that there is a Pythagoras theorem, if I say that the hypotenuse square is equal to the two sides square, if I say that the sum of two sides square, there is a theorem for us. We can clearly understand it's a right angle triangle. Hence, it is proved. But now, apart from that, so how can you say that these two are in the same network, or else these three we have to follow three octets of an IP address? How can you say that? I think you might be seen in somewhere else. But my question is, how can you identify these two belongs to the same or different? If same, how can you say that they are same? If different, how can you say that it's different? So by looking with only the IP address, you cannot say that they belongs to the same network, or else they belong to the different network. You cannot say that. So how we will identify, or else how machines will identify, or else how humans will identify? To identify that, we are having a concept called as subnet. We are having a concept called as subnet mask. What is this subnet mask? See, try to understand. IP address is different. IP address is helpful for establishing the communication between the devices. Okay, try to understand. Don't both. IP address is different and subnet mask is different. What is subnet mask? Subnet mask is also a 32-bit address. It is also a 32-bit address which is helpful for identifying the network and host portion of an IP address. So by looking into the subnet mask, we can say that the IP address network and host portions. Host is nothing but so the numbering which is given to the system. Okay. So again, I'm telling you, who will decide this? This is in the same network or different network. That can be decided by the IP address. Okay, are you able to understand this? So who will decide that? Like we are having brains, my brain will decide that this person belongs to this particular organization and this person belongs to the different organization. In the same manner, so for networking devices, the IP address will identify that this particular computer belongs to this particular organization and this particular computer belongs, this particular computer belongs to the different organization depending on the subnet mask. Okay, so subnet mask plays a crucial role to identify the IP address networks. Okay, so IP address networks can be identified by your subnet mask. Able to understand here? Now, how it is going to identify it? So I am saying that subnet mask is also a 32-bit address. Likewise, the IP address subnet mask is also a 32-bit address. But be very careful. IP address is different and subnet mask is different. Again, I am repeating for you. IP address is different and subnet mask is different. So based on the subnet mask, you can identify whether the IP address is in the same network or different network. So simply, if I have to say, subnet mask will also have 32-bit address and they will be divided into 4 octets. IP address will also have the 32-bit address and they will be divided into 4 octets. Now, in each octet, in subnet mask, one represents network and 0 represents host. 1 represent network and 0 represent host. Okay, so now how we are going to provide this configurations? So try to understand. If for example in the subnet mask, if the first subnet is all ones, there are 8 ones. Okay, there are 8 ones in the first octet. So in the second octet also, if you are having 8 ones, in the third octet if you are having 8 zeros, in the third octet you are having 8 zeros, and in the fourth octet also you are having 8 zeros. So the meaning itself, it is saying that, so there is an IP address, and under IP address you will have the subnet mask. So this is the IP address, for example 5 6 7 8. This is the IP address. Under that you are having the subnet mask. Okay, now what subnet mask is saying? Subnet mask is saying that, so I am having the one number in 2 octets. I am having one number in 2 octets. So if you convert this one into digital, if you convert the one into decimal format, you are going to get like this: 255.255.0.0. How I know that it is 255? 8 ones in binary number format is called as 255 in the decimal number format. So now what I will do here is binary to decimal. Look at here. Convert 8 ones into decimal format. What is the output that you got? You got that 255. So that's about how you are going to get the configuration. Okay, that's how you are going to convert the binary to, what I can say, decimal conversions. Now, when you see here, what I'm saying, in the first octet, you are having all ones. In the second octet, you are having all ones. So totally, there are two networks. For example, there is an IP address like this, 10.1.1.100 with the subnet mask 255.255.0.0. So in subnet mask, there are two octets which are coped up with network bits. So this 255, if you convert that into a binary format, all ones will be coming. So 255 is equal to all ones, which means that the first octet of this IP address is the network octet. And if you see here, there is 255. What is the meaning of that? So this 255 will represent that the second octet of the IP address is also the network octet. So who is the deciding factor for the IP address, stating that the first two octets or else first three octets or else the first octet is the network octet? Depending on what? Depending on the subnet mask, we can identify the IP address network. For example, there is an IP address like this, 10.2.1.100 with the subnet mask 255.0.0.0. So the subnet mask says that in the first octet, I am having all network bits. So the first octet in the IP address is the network bit, and rest of them are all the host portions, which means that you can create some 1 crore devices. You can connect 1 crore devices if at all, if you are having only single network. If you are having two network portions, then you can create some 65,000 devices. In the same manner, if the IP address looks like this, 10.23.45.some 100 with the subnet mask 255.255.255.0, then we can clearly say that the subnet mask representing three network portions, which means that the first three portions of the computer or the network portion, and the last portion is the host portion. Okay, so this is how you can identify, depending on the subnet, this is how you can find out the IP address network portion and the host portion. Okay, I hope you understand this. Any questions here? Do you understand what I said you here up to now?
Could you please repeat, Chaitanya, this one? How you are deciding the sub? See, yeah.
Go on. So you want me to repeat the entire concept?
Not entire. Below one, you mentioned like 255.255 three times, right?
That's why I asked you to look after the binary to decimal conversion in the previous session.
Okay.
This 255, whatever the 255 is there, this is the decimal number, right? So if you convert this decimal number into the binary format, what you are going to get? In this octet, you will get all ones.
Right.
I would understand.
Right.
So if all ones are there in the subnet mask, what it is going to represent here?
Network.
One represents the network. So the subnet mask says that so the user gave the subnet mask as 255, which means that in the first octet I am having 255. So the IP address first octet also the network portion. It is called as network portion. In the subnet mask there is another 255, which means that there are 8 ones, which means that the second octet is also the network portion. The third octet also having 255, which says that the third octet is also the network portion. So depending by seeing the subnet mask, whatever the subnet mask that you are seeing here, just by looking the subnet mask, you can say that these three are the network portions and this is the host portion. So first of all, you need to check what is the subnet mask. Depending on that, how many ones are there? Depending on that, you have to identify what is the network portion and what is the host portion in the IP address. Getting the point here?
Right. Yeah, thank you.
Any further questions? Questions, please.
So directly, can we not seen through IP config?
If you give IP
Similarly,
config also, IP config also, it is going to give you the subnet mask. The without IP address, you won't. Sorry, without subnet mask, you won't have any IP address. IP config is a command which helps you to identify the IP address of your computer. I go with IP config. See, I have the subnet mask here also. Everywhere, wherever you find the IP address, definitely there will be a subnet mask. Without subnet mask, you are not able to find the network and host portions of the IP address. Is it clear?
Okay, yeah, that's what I was just. Thank you.
IP config is a command which helps you to identify the IP address of your computer. Okay. Any another question?
Yeah, Chaitanya, can you please tell us the method to calculate the number of device we can have in particular subnet?
To check the method,
Which, yeah, what is the
how many
logic?
devices I can connect? That is what you are
Right, right,
about to
right.
check.
As you said,
Yeah.
in the
Fantastic
subnet where
question.
we are having in the first subnet, right?
See,
So as
I'm
you
coming to
told
that.
us,
I'm coming to that. I'm
okay,
coming to that. See, if you see the first subnet here, okay, if you see
mm-hmm.
the first subnet over here, I'm asking about bits, not about the decimal number. Here you can see 255, 255, 00. These are all the decimal numbers. Okay. If you
Right.
convert that into the binary format, how
Mm-hmm.
many network bits that you are going to get for this particular subnet mask? How many network bits? I'm asking about the
Uh,
total network bits.
our total will be 16. Like there will be two octet, right?
Yeah, 16 network bits you are going to get. How many zeros, which means the host bits that you are going to get? How many zeros? Here we have, this is the decimal format of 0. But when
Mm.
you convert into the binary format, 8 zeros will be there in the one octet. And if you see the another octet, there also you will have
8
8
zeros,
zeros. So total, how many zeros you are having?
16,
In zeros, right? So
right?
what is a host? I said previously in the last class, host is nothing but a device, right? Host is nothing but a device. So if you see here, there are 16 bits. There are 16 bits. 16 host bits are there. 2 to the power of 16 minus 2. So that is equal to 16,536 minus 2. Sorry, 65,536 minus 2. Total you will get 65,534 devices. Now, if you see this particular subnet mask, how many host bits are there? How many host bits are there?
24.
24 host bits are there. So if this is the subnet mask, how many devices we can connect? 2 to the power of 24 minus 2. If you calculate, you are going to get 1 crore 67 lakhs 77,216 IP addresses minus 2. 1 crore 67 lakhs 77,214 IP addresses. 214 devices you can create if you are having the subnet mask like this. And if you see the last subnet mask, 2 power, what is the host bits?
8.
8. 2 power 8 minus 2 is equal to 256 minus 2, 254. You will understand how many bits you can connect. I mean, how many devices that you are going to get. You understand it?
Oh, yeah, I got it. Thank you.
Okay. Any further questions?
Nothing from my side.
Okay. Fine.
And good.
Yeah, cool. So that's about the number of host or else number of devices will be there depending on the subnet mask, you can understand. So now if you see here, this particular subnet mask can be represented in a slash value. Whatever the subnet mask that you are seeing here, this can be represented in a slash value. So how many number of network bits are there in this subnet mask? How many number of subnet network bits are there in this subnet mask?
16.
So the slash value will be 16. If you give an IP address, if you have given an IP address, so in the examinations, they won't give the IP addresses like 10.1.1.100, 25, 255.255.0.0. They are not going to provide like this. They are going to say 10.1.1.100/16. Okay, this is the device that I am having. and it has to connect to one more device, that is 10.2.1.100/16. Just I am telling you an example. It is not going to come in your examination, but they are going to ask you whether these two belongs to the same network or different network. So can you tell me whether they belong to the same network or different network? So let us see what is the first IP address that is given here. This is the first IP address, right? So now
Right.
I will paste it over here. /16 means what is the subnet mask? 255.255.0.0.
0.0.
Okay. And here also you are having one more subnet mask, that is this one, or else IP address and subnet mask. So what is the IP address? 10.2.1.100. What is the subnet mask over here? 255.255.0.0. Okay.
0.
Now whenever anybody asks you whether these two IPs belongs to the same network or different network, can you tell me whether they belongs to same or different? So what is the first? So how many network portions are there in the first IP address? In the first IP address, how many network portions are there, or network octets are there?
16.
Huh?
2 octet, sorry.
2.
16-bit 2 octet.
2 octets. So what are the 2 octets? First 2 octets are the network octets, right?
Right.
And what about the second IP address? In the second IP address also you are having
2 octet.
2
2
octets.
octet.
But when you see the 2 octets, 2 are the network octets. In the first IP address, there are 2 network octets. In the second IP address also, there are two network octets. 10.2 is the network octet. Now, when you see these 2 network octets, do you find any difference in the network octets? The first octet is same, 10. But what about the second octet? What about the second octet? In the second octet, you are having 1. In the first IP address, in the second octet, you are having 1. And when you come to the second IP address, second octet is 2, which means that the network portion of these 2 IP addresses are different. How, sir? The first portion is same, no, but the second portion is different, no. That is the reason. If you are having 2 network portions and 2 network portions should be same, then only these 2 IP addresses are in the same network. If 2 IP addresses are having 2 different numbers in network portion, then they will come under the different network. So can you tell me whether these 2 IPs belongs to same or different?
Different network.
Different network. Okay. For example, if I queue here, now can you tell me whether they belongs to same or different?
Same network.
Both are same. I cannot provide 2 IP addresses with the same IP, or else I cannot provide the 2 devices with the same IP. For example, you are in a class. So when you are in the class, for example, your name is Shiva. Okay, and into the class there is another guy came and his name is also Shiva. Now both are having the same name. Now what happens here?
You will give Seva 1, Seva 2 like that.
If we are not giving like that, right? So in a class, if we have 2 members with the same name, if there is no roll number thing, there definitely there will be a conflict. That's why you are saying 1 and 2. Okay. Here also I am having the same IP addresses. I cannot provide the same IP addresses for 2 different devices. If I provide the same IP addresses for 2 different devices, then there is a network IP conflict. Okay, the device will not accept. It is going to throw you an error. Already the IP address is in the network. Okay. So the first and foremost condition here is IP addresses can be differentiated by subnet mask. Okay. In a network, there should not be same, or else in a network, we cannot provide same IP addresses to 2 different devices. We can't provide same IP addresses to 2 different devices. And the next one is, if the IP address network portion are different, if the IP address network portion, network octets are different, then those two IPs belongs to, then the IPs belongs to two different networks. Yes or no? Two different networks. Understood? These are the main things that you need to understand. Okay. Now, a basic question for you. 10.1.1.100, 255.255.0.0. So this is IP address and the below one is the subnet mask. Now, what is the host portion? How many host portions are there? How many host portions are there?
Two.
Two.
Host portions are there. So remember one thing, whenever we are discussing about the host portion, the numbering whatever we are giving for the host portion, that number belongs to a device. Okay, so for example, if you are attending to a class, in the class your roll number will start from 1, 2, 3 and so on. You can go for hundreds and thousands of numbers. Okay, which means that, is there any roll number that starts with 0? Any number or also any people? So in the class we cannot start the numbers with a 0, so obviously there is a roll number that starts with 1. Okay, in the same manner, any device, if it is in the network, it should not start with 0, it has to start from 1. Okay, so now if you can see here, what are the host octets? The host octets are, last two octets are the host octet. If the last two octet of the host of an IP address are 00, then it is called as a network ID. Sir, why only last two octets? Because the subnet mask is 255.255.0.0. So that's the reason the last two octets, if they are zeros, then that is called as a network ID. Now, if I go here, 10.1.0.0, 255.0.0.0. So now how many host octets, by seeing the subnet mask, you can say how many host octets are there?
3.
3. Can I call it as an IP address or network ID? The below one. Just forgot about this.
Network ID.
This is called as a, I'm talking about this. Whether can I call it as a network or IP?
Network.
Think once before you answer. Again. So what I am saying, if the host portions are 0, so here you can see how many, by seeing the subnet mask, I can say that the IP address, first portion is the network portion, remaining 3 portions are the host portions. By looking at the subnet mask, I can easily say that the first portion is the network portion, remaining 3 portions are the host portions. In host portions, if you have in any portion, if you have one non-zero number, then that is called as an IP address. Again repeating, in host portions, if you are having any portion, if you are having one non-zero number, then that is called as an IP address. Okay, little bit confusing. Now, can you tell me whether it is a host or IP? Can you tell me whether it is a host or an IP?
It's a host.
Host.
Network ID or an IP?
Sorry, network ID. Yeah.
Okay. So it is a network ID. How can you say that it's a network ID? Because in the subnet mask, there are the last portion is the host portion, and here the last host portion is 0. So that's the reason it is called as a network ID. So the final question for you, 10.1.0.0 and 255.255.0.0. This is called as a, what is this called as? This is called as a
Network
ID, right? So 10.1.255.255, 10.255. You see the subnet mask 255.0.0. So this is called as a broadcast ID. So this is called as network ID and this is called as a broadcast ID. Why it is called as a broadcast ID? If you see the last two octets, So you are having 255, which means that it is totally coped up with the network bits. All ones are there. In the last portion also you are having all ones, which means that if the host portions are completely filled with ones, then that is called as a broadcast ID. And if you see in this example, the host portion of an IP address is totally coped up with zeros, then that is called as a network ID. These two IPs we cannot assign to the system. So if you see here, let me show you that these two IPs we cannot assign to any one of the computer. Look at that. So I will assign like this: 10.1.0.0, 255.0.0.0. If I assign this, look at that. What I am getting, the combination of IP address and subnet mask is invalid. All of the bits in the host address portion of IP address, host address portion means third and fourth octet, all of the host address portion of IP address are set to 0. Please enter a valid combination of IP address and subnet mask, which means that the entire portion of the host octets are totally coped up with 0. So then that is called as a network ID. And if I change it to 255, 255, look at that. This is also I'm getting error. What is the error? The combination of IP address and subnet mask is invalid. All of the bits in the host address portion of IP addresses are set to 1. Previously it is saying it is set to 0. Now it is saying it's set to 1, which means it's a broadcast ID. So previously whatever we have set, it's a broadcast network ID. Now whatever 255.255 that we have set, it's a broadcast ID. Broadcast ID. Okay. Network ID. So now why I have subtracted to C? Sir, why 2 power 16 is there? Why you are subtracting to? Nobody asked me this question, so I'm giving you the answer. Why? Because I am deleting these two IDs. One is network ID and the other one is the broadcast ID. So that's the reason I'm subtracting 2 from each and every subnet whenever I am calculating. Understood?
Yes, great.
Okay. So that is about your IP addressing and total how you can calculate an IP address. Why I am saying all these things, because whenever you go to the, whenever you are creating a VPC in AWS, whenever you are creating a VPC in AWS, what you have to do here, look at this. Hold on. So VPC will be in the networking and content delivery. You can see there is a service. Under that service, you will have the VPC. Service, network and content delivery, VPC. Here you have to give the VPC is equal to create a VPC. Whenever I am creating the VPC, so you can provide the name, but you have to provide the CIDR. I will provide like 10.100.0.0/16. So what is the /16? What is the /16? Is a subnet mask which is having 255.255.0.0. Okay, that's the reason I am saying you all these things. So these are all interlinked to your AWS. Whatever we have discussed up to now, these are all interlinked to AWS. Okay. Now, if there are 65,000 devices in a network, okay, what I'm saying, if you are having the subnet, if you are having the IP address and subnet mask like this, total how many devices you will have? You will have 65,000 devices in a network. Now, is it possible for you to work with 65,000 people at a time? For example, you are in an office and you are the manager. You have to manage 65,000 people. Is it possible for you?
No,
No. So what you have to do?
split into chunks.
You have to divide into sub networks. Okay. In the same manner, whatever the IP addresses, whatever the network that you are seeing, that network should be divided into small networks. How we are going to divide that? Whatever the VPC that we are creating, we have to divide that VPC into small networks. So that is called as subnetting, which we are going to discuss in the next session. Okay, so tomorrow we will discuss about subnetting. Just to go through the IP addressing concept once, you can find lots of YouTube videos, and you can follow my video today, whatever I have given, or else you can follow the YouTube videos. So just to try to understand the IP addressing concept, and later from tomorrow we will start the subnetting, and this week we will bind up the things, and from next week we will start the AWS configurations. So that's it from my end. So whatever you are having your doubts, you can ask me now. Questions, please.
So, sir, from tomorrow, what will be the timing?
Tomorrow the timing will be 8 o'clock only. Tomorrow also there is 8 o'clock.
I think you told like it will be 7 o'clock.
That we are deciding. We still didn't decide right now.
Okay.
Anything else from my perspective, or which I have to which I have to tell?
So how many maximum number you are expecting in this batch? I mean, uh, can we discuss in same way that currently we are doing?
Yeah.
Okay.
If there are some 100 members also, my training will be in the same manner. If there are only one member or two members also, my training will be in the same manner.
Okay. Great. Thank you.
Okay, so that's it from my end. Have a nice day, and we'll meet in the next session. And happy Independence Day in advance.
Yeah, same to you.
Bye.
Thank you, Chaitanya.
Thank you.
Same to you. Thank you.
Yeah. Thank you.